Hey, good morning. This is Walt Miner here from Automotive Grade Linux. I'm the community manager, and
I'm Jan Simon Möller. I'm the release manager for AGL.
yeah, we're here at Embedded World 2025 in Nuremberg, and we'd like to show you some of the new developments, including AGL on RISC-V here in our booth.
There's a lot of developments at AGL.
Absolutely, we've been doing a lot of work over the last year. We'd like to show you some of the cool new stuff we've got going on. So, major development in AGL has been adding RISC-V support over the last couple of years. We've been running on QEMU, on some other boards, and now we've got Flutter, our all-new Flutter UI running on this VisionFive Revision 2 RISC-V board.
And is it smooth?
Oh, holy cow, look at this. Very responsive UI, audio.
This graphics acceleration. All right.
Yeah, very responsive UI. You can play with the HVAC here, up and down.
So would you say this could be totally in a production car?
We're really looking, so RISC-V is kind of, whenever you talk to any of the RISC-V board companies, we're about 2 years away from having a RISC-V production-ready board. But this is a developer board you can buy today, this VisionFive 2 board. And what did it cost, John Simon?
It's about $120.
$120, so
yeah.
Potentially it brings lower, more affordable EVs in the future or something like that?
Absolutely. Well,
Yeah,
RISC-V is really being used in the automotive industry throughout China right now. It's really been popularized, especially in ECUs and in lower level modules. And now the functionality is really creeping up into the marketplace.
And so everything you do is open source, and you collaborate with the whole world, basically, right?
Absolutely. Everything that you see here, all these demos that you see here today, you can download on our download server today. You can play with them on this RISC-V board, on a Raspberry Pi 5.
So if you go to docs.automotivelinux.org, there you find the steps to reproduce exactly what you see here, because all of this is open source, including the demo UI. And you can recreate either this Flutter demo, but we also have a Qt-based demo.
And VisionFive 2 board, where is it possible to get those?
Yes.
You can get them, where did you buy this one, on Mauser or?
Yes.
Yeah, any of the distributors have them.
Yeah.
All right.
Yeah, so let's go over here. So if you've seen AGL in the past at any other trade shows, you're probably familiar with our green machine here. And now again, you're seeing our newest Flutter demo running on IVI system as well as instrument cluster. So we've basically been modifying this demo over the years. We've got the steering wheel attached to it, and now in the last few years, we've also added a gateway, a telematics gateway, that basically collects data from this, what we call our demo control panel here. So as you turn on these buttons, as I turn on the flasher here, you'll see it shows up over there. So this is you could basically simulate any ECU function with this demo control panel. Jan Simon, you want to explain how this works?
Yeah, so this has been a Google Summer of Code project, which we developed over 2 years. And we can basically inject signals over the CAN bus wire. You see here our nice wires. Here's our simulator. This is the gateway. It picks up the CAN signals. It puts them in the middleware. For us, that's the CUXA data broker. And the applications, they don't need to deal with the CAN bus. They can query the data broker. So that helps tremendously to keep the applications portable across different vehicle models.
What is this data broker?
You could say it's an automotive MQTT-ish system. MQTT, you can basically write data anywhere. Here we have a well-defined data structure. It's called VSS, Vehicle Signal Specification. It's like an MQTT with a tree structure.
It basically, VSS, it's a Covisa project. It defines the data taxonomy for a vehicle. So it gives us a common way of talking to different devices across the spectrum.
When you talk about Google Summer of Code, do you have contributors and developers around the world, or where?
Oh yeah.
Who's working with AGL?
Well, the Google Summer of Code students come from around the world. We've had 2 to 3 students every year for probably 5 or 6 years. We had one GSOC student that developed this. And again, talking about being able to run AGL on inexpensive hardware, if you peek back here, we've got this running on the, what is it, the Pi? What is the Pi?
That's 400? A Pi 400.
It's just a Raspberry Pi and a keyboard, and that's running this whole demo control panel.
Module. So our software runs even as low as a Raspberry Pi 4, Raspberry Pi 5. So if you want to try it out, we have ready images that you can try at home, and you will find that on our download server as well. So if you want to play with kind of such an UI and try it out, this is exactly what you can reproduce.
So let's try it out a little bit.
Yep.
So yeah, this particular one is running on some Renesas R-Car H3 hardware, and you'll see.
If you change the temperature, you see the effect over here. And if you change the fan speed, you will see that the fan in the middle. Yep.
It's kind of hard to see the fan.
Turn it off, then we'll see it.
So in the automotive market, it's important to be like 100% reliable, extremely fast UI. Otherwise, there's accidents, right?
Oh yeah, so functional safety is a key part of any software in the vehicle. And we're relying on both our project, which is under the Linux Foundation, as well as the ELISA project, enabling Linux in safety applications. And we'll actually, later on today, we'll be having some of our ELISA experts for a little roundtable talk here at the AGL booth.
The ELISA is about security?
Safety. It's about safety applications. Security is, safety and security really are separate topics. A lot of people get that confused, but safety is about if your instrument cluster goes blank, turns off, what should happen then to make sure that the car acts in a safe manner and the driver is not either injured or killed.
Is it cool to know that millions of cars are running on your software in the world already?
Yeah, it's already in use in cars. Especially from Toyota,
Subaru. And it's coming soon in a few other manufacturers that'll be announced later on this year for model year 26, so later in 2025.
And they don't have to say if they use your software, right?
No, absolutely not. We know that Renault, for example, self-reported they were using our software, but they're not even member companies. So you don't even have to be a member. You can download all this software for free and play with it.
And companies like Tesla and stuff, there's so many Linux-based systems, right? So everybody who uses Linux basically uses the work that comes out of here, right?
Well, not so. Tesla has their own fork of Linux, and they do their own thing. But yeah, many of the major companies, 20 million vehicles per year get built running some version of AGL software.
And it's just going to accelerate more and more.
Absolutely. The predictions are that AGL will continue to take off in the marketplace, and we're seeing more and more vehicles come onto the market every year.
How smooth is it with the Flutter?
It's very smooth. The developers behind that are from Toyota, and they do a really great job in making sure that the UI works on different platforms. We have seen it on RISC-V. Here we have it on an R-Car, so it's an automotive software. It's an automotive hardware platform, and it's optimized for that.
And it's near native performance when it's Flutter, right? It's
very
smooth.
Yes. And Joel Winarski at Toyota has been doing an excellent job of keeping AGL and the internal Toyota work very, very up to date on the Flutter builds. We're usually within 1 or 2 releases of the Flutter tip of the tree. So what you're seeing here is very, very recent software from Google and from us.
And every time Flutter gets updated, you can use everything they do?
Within a few months, yeah. Usually we're about a month or 2 away from getting that pushed to us from Toyota.
All right, and I guess a lot of applications can enjoy this. And when you design a new car, you want to have a new, like design language, and it's easy to implement when it's Flutter.
Absolutely. So in a minute, we'll introduce you to our ICS team that did this UI in about 8 weeks. I just want to talk about one other thing about AGL. So this year, the big topic within the automotive industry is software-defined vehicle. And how do you create a software-defined vehicle? AGL and Panasonic in particular within AGL have been doing a lot of work on enabling software-defined vehicles and enabling off-board, cloud-based solutions for developing your software. So you don't necessarily even need this hardware. Right now, you'll see this board is actually running a hypervisor for the IVI and the instrument cluster. So these are not running bare metal.
So, these are two virtual machines that run the instrument cluster and the IVI side by side. And what Panasonic did is they worked hard on adding more and more VirtIO features. So basically the goal is that we can take exactly the same image and run it in the cloud, basically allowing for rapid development, rapid testing, while basically you take exactly the same image that you tested in the cloud and move it down into the car.
So when in terms of SOFI and the alliance that people are doing over there, you are very much implicated in that.
Oh yeah. We've been meeting with the SOFI people very regularly. We just had a meeting with them a few weeks ago. We believe that we are at or near SOFI compliance as it is defined today with this KVM solution that we have. Now, Honda recently rejoined AGL as a silver member, and they've proposed that AGL creates an out-of-the-box software-defined vehicle reference platform. So we're going to be basically taking this software as the basis for that and possibly adding Zen instead of KVM, as well as KVM, and then adding Zephyr as another virtual machine that can run in the vehicle.
What would Zephyr be useful for example?
But basically the safety island, as you talk about ELISA and functional safety, you'd put the functional safety applications and functions in the Zephyr machine. Also, we're trying to move some of our CAN communication off of the Linux A kernels into something that's controlled by Zephyr to make that functionally safe.
And when you talk about the SDV Alliance, is it similar to what SOFI is doing?
SDV Alliance is it's an alliance of alliances that we're not involved in. I can't comment on what they do at all.
And to be a member of the AGL, how does it work? And it could be more and more vehicle brands could join.
Oh, absolutely.
Do you have to dedicate engineering?
So obviously we encourage all of our member companies to dedicate engineers to the project. But to join AGL, you have to be a member of the Linux Foundation, and then from there you join AGL as a bronze, silver, gold, or platinum member, and you contribute different amounts of money. We use some of that money for development. We use some of that money, of course, to keep up our infrastructure. So now you want to talk about Flutter some more and how easy it is to develop on Flutter? Let me introduce you to Justin Noel from ICS.
All right.
So
we can get you mic'd up.
Okay.
All right, and you can introduce you a bit. We're going to see.
Yeah. So a few years ago, when AGL made this move to Flutter, initially, we talked about Google Summer of Code. Initially, we had a couple GSOC students create a really primitive version of our old, something based on our old Qt-based demo. Then about a year and a half ago, we engaged with ICS, who basically used some of their designers and started with a blank sheet of paper to create this really beautiful looking Flutter demo. And this here is Justin Noel from ICS, and he can talk a little bit about what they did and how they got here.
Sure. So the CES before last, we were contacted by AGL to make a new reference HMI that would debut at CES. And they specifically requested that it be implemented in Flutter. We had some of our user experience designers and artists at ICS create this look and feel for a home screen, HVAC, media player, settings. And this is a reference of what you could develop when you use AGL. So AGL intentionally doesn't prescribe any particular user interface, nor suggest any particular user interface technology. Flutter is very attractive for its open source license, which meshes well with AGL's philosophy. Google releases it, Flutter and Dart, under a BSD license. It uses a Flutter embedder from Toyota Connected that's also has a open source license and is included in AGL. After CES, between then and last year's Embedded World, ICS did the same design, same art and graphics and look and feel, and we implemented it in the Qt and QML framework. And this is showing off some of the parity between Flutter and Qt and QML, and the fact that the design of AGL with its services-based architecture allows you to easily implement a user interface in whatever technology you choose.
And so the round one there, is it Flutter or Qt?
This one is actually Qt, and it's actually the same application as the screen one. It uses the same C++, but has a different QML, basically theme on top of it.
How much do you enjoy working with Flutter and Qt?
Oh, I love user interfaces. I like being the face of the application that the user actually touches and uses. And we have a very long history in Qt, and we have, in the last few years, have seen Flutter becoming the rising technology when it comes to mobile phones, but also embedded devices. And Toyota's work really increased the level of that adoption.
I guess people really enjoy when the user interface really makes sense, it's easy to use, and all the icons are the perfect size, the place. Are there studies like to make sure everything is just perfectly set up?
There is. There's a whole science to this. In fact, I'm an engineer, and a very long time ago, we realized the engineers make fairly poor user interfaces. So I'd like to thank the design staff at ICS, known as Boston UX, whose entire careers are dedicated to understanding what users want and what feels good. And there's a whole design process behind this that allows, the process allows for the creation of very beautiful things that can then be implemented by the engineers, which is also important.
How hard is it to customize or change things, or make different versions?
Well, you can see here that these two UIs are insanely different, but it's really just a customization of the graphics. The actual application code and logic and what runs the car all stays exactly the same.
What do you think is the performance?
The performance is good. You could click around and you might see that some technologies work better than others, but everything improves every day. And also, you need to take into consideration your target hardware, whether you're running a Renaissance R-Car platform, which is a very powerful machine, or you're running on little Raspberry Pi 4s.
All right, and they've got GPUs, NPUs, stuff. I wonder how much is possible to use in the AGL.
Well, we're really based on Weston 13, and kind of at the mercy of our board vendors. Whatever graphics driver and whatever GPU is on there, we're really relying on them to exploit that GPU through the BSP. Although more and more we're seeing open source graphics becoming popular, especially Mali with ARM. But we're not really there yet with the AGL hardware for having that Mali graphics.
Do you think the NPUs and the AI acceleration could be integrated somehow in the way things are done?
Yeah, we absolutely see that coming. Absolutely.
And what could be your role with that?
So we're thinking that ADAS is a use case there, integrating sensor data, looking at what the driver's doing, looking at the road going ahead, lane avoidance, things like that. Those will all then get gradually implemented into these high compute platforms for software-defined vehicles, and you can then mix and match where that functionality goes.
And I guess with EVs especially, they want to save power and make SoCs that are so smart and saving power.
Absolutely.
And it needs to be implemented right.
Absolutely, and that's something that we'll be focusing on in the future here.
All right, so thanks a lot for the tour here at the Embedded World.
Oh, thanks for coming, and we'll see you next year.